Welcome to Section 8.1, Ratio and Proportion. The objective of this lesson is to recognize and work with ratios and proportions and calculate geometric means. For our homework, we'll be working on page 329 through 331, 1 to 21 the odds, and 24. So first, let's get some vocab out of the way. A ratio is a quotient of any two numbers. So really, any fraction is considered to be a ratio. 5 over 9. A over B. X plus 3 over Y minus 19 are all ratios. Proportions is an equation stating that two or more ratios are equal, such as AB equals AC, or A with the colon B equals C colon D. In a proportion containing four terms, A over B equals C over D, we have two pieces that come up, extremes and means. The extremes are the first and the fourth terms, so the first thing you would read and the last thing you would read, the A and the D. The means are the things in the middle, the second and the third thing you would read, the B and the C. In a proportion, the product of the means is equal to the product of the extremes. Can anyone think about what that actually is? Well, let's kind of take a quick peek at this. The product of the extremes is equal to the product of the means. What are we going to be doing there if we're taking the products? Cross multiplication. If the means in a proportion are equal, either means is called the geometric means between the extremes. The arithmetic mean is the average of the two numbers. So let's kind of draw out an example to go with this. In this example of geometric mean, x over 5 equals 2 over x. When we look at those extremes, the first and fourth term, they're exactly the same. The other two could be different, but when we have either one set the extremes or the other set the means are identical, then we have a geometric means. The arithmetic means is what happens when we try and take an average, such as if we have the numbers 3, 8, and 9. We add them together and divide by the number of numbers, and we get the arithmetic mean, something that we're used to doing from pre-algebra. Let's try some examples now. If you think you know what you're doing, let's give it a try. Press pause and check your answers. If you're not too sure what you're doing, copy down the problem, and we're going to do this together in just a second. So what we have here is 3 over x equals 7 over 14. And you might ask, should I reduce this 7 over 14? You absolutely could, but it's not necessary. Anytime we have a proportion, two equal ratios, we are going to cross multiply. We're going to multiply that 3 with that 14 and that 7 with that x. And what I end up with is 42 equals 7x. And now we're going to solve for x. Divide 7 to both sides, and x equals 6. For our second example, we have y plus 2 over 5 equals 6 over 9. Again, if you want to reduce, you absolutely can, but it's not necessary. So we're going to cross multiply once again. That y plus 2 gets multiplied with that 9, and that 5 gets multiplied with that 6. So now, for our next step, when we cross multiply there, I'm multiplying 9 times a binomial. So that binomial needs to go in a parenthesis, which means we have to distribute. When I multiply 6 times 5, I get 30. Once I distribute, I end up with 9y plus 18 equals 30. I subtract 18 to both sides, and 9y equals 12. Divide both sides by 9 and reduce, and I get y equals 4/3 or 1 1/3. For our last example, we're going to find the mean proportional between 4 and 16. So here we go. The mean proportional is when either the means or the extremes are exactly the same. I'm going to let my extremes be the same. The extremes are the first and the fourth term. For our other two numbers, they go in as the other pieces, in this case the means, my second and third term. Once again, we need to cross multiply. X times x and 4 times 16. So here we go. X times x gives me x squared. 4 times 16 is 64. We have to get rid of that squared with that 64. Opposite of squaring is square rooting, which gives me x equals 8. So these are our last set of examples. and definitely the most difficult examples we're going to encounter. For this first one, we have if 2x equals 5y, we want to find the ratio of x to y. Now let's think about what it means to be a ratio. Ratios are expressed as fractions, in this case x over y. So that's our goal, is to have one side of the equal sign be x over y, and everything else to be the other one. Now, if we want x over y, we want x to be on top. In this case, the x is already on top of the left side. So the left side is where we want to get that x over y. In order to do that, the first thing that I'm going to do is I'm going to divide that y to both sides. When I divide both sides by that y, I end up with 2x over y equals 5. We got the x over y, we have to get rid of that 2. To get rid of that 2, I'm going to divide it to both sides, and that leaves me with x over y equals 5 over 2. For our second example, we have x over y equals a over b, and we want to know, is that equivalent to x minus 2y over y equals a minus 2b over b? So this is not going to be easy. In order to tell if they're equivalent, we have to have both of these equal identical things. So the first thing I'm going to do on this left one is I'm actually just going to cross multiply. And when I cross multiply, I get xb equals ay. Now, I want to try and change this into the exact same thing. So again, I'm going to start off by cross multiplying. And when I cross multiply, I end up with xb minus 2yb equals ay minus 2by. Remember, when you multiply, it doesn't matter which order you multiply in, you end up with the same product. The next thing that I'm going to do is I'm going to add this 2by to both sides, remembering 2by is the same thing as 2yb. And what that gives me is the exact same thing as I have on that first proportion. xb equals ay. Our last one. Our last one looks kind of similar to the one above it, but it really is very different. I want to show that AB equals A over B equals C over D, and A plus B over B is equal to C plus D over D. We want to show that they're equivalent proportions. Well, this is going to be slightly more complex, so let's see what's going to happen here. First thing that I'm going to do is I'm going to look at that first proportion, and what I'm going to do here is I'm going to add the exact same thing to both sides. So think about it. If we had 5 equals 5, something that's equivalent, and we added 1 to both sides, we'd end up with 6 equals 6, something that is the exact same thing. Now, the next thing is I know when I add or subtract with fractions, I have to have common denominators. And if I want to add or subtract using a unit of 1, I want my top and bottom to be the same thing. So this 1, I'm going to end up expressing as b over b, which is 1. And the second one, I'm going to express as being d over d. Now, what I'm going to do is our rule with adding and subtracting with fractions. You add or subtract the top, keep the bottom the same, and that's what I get. A plus b over b equals c plus d over d. We're going to do a few more examples, like this first, second, and third one tomorrow in class when we do our exploring. These are by far our most difficult types of questions we're going to encounter in this section, and we want to make sure that we totally understand them. Last but not least, the moment that I know you've all been waiting for, the answers to our homework. Again, to refresh, our homework is going to be 1 through 21, the odds, and 24. Make sure if you're starting your homework, you're going to be checking your answers. Otherwise, as always, I'll be pulling up tomorrow as we're working together on this in class. And as always, have a good one.